All right, so let's convert into matrices and let's try and solve it. 1, 1, minus 1, 2, 3, minus 3. Oh, 2, yes, thanks. Geez, always make mistakes. Okay, so here's our starting point. So let's leave the first one as is, that's okay. This one, I'm going to always use row 1, so I'm going to say row 2 times 2, and then take away 1 row 1. So that will always give me 0 here. Twice that, take away that is 3. Twice that, take away that, negative 3. Twice that, take away that, negative 1. Okay, this one's going to be 0. How will we make it 0? We'll do twice row 3, take away 3 times row 1. That's 0 anyway. Twice this is negative 3. Negative 3. This, take away 3 times that. 6 minus 3 is 3. And this, take away that. To make a 6 here. And I cancel with 6 here. Yeah. You always go back to row 1 with the first one. So let's 18 take away. Is it 1? It's 1.
So those are power. Are they power or no? They're not power.
Well, let's look. Let's just do our system. 2 minus 1 minus 1, 5. Let's leave this one as this. And let's try and get rid of this last one. Yeah, so row 3 minus row 2 gives me 0, 0, 0. What does that mean?
That means they're cross on one.
Oh yeah, plus. Yeah. They're already the opposite signs. Yeah.
All three have one common line.
All 3 have one common line. That's what this means. A 0, 0, 0 at the end means there's infinite solutions. Infinite solutions. That's what this means. Infinite solutions. There's a load of stuff that will work here for y and z, for example. If you multiply a number by 3 and then multiply it by negative 3 and get 1, you can do that loads of different ways. So there's infinite solutions here. And when we did systems linear equations, we found what that line would look like. Or we get an equation for it by letting z equals t. And then what's our next step? 3y minus 3t equals negative 1. And then we can rearrange for y. So 3y is equal to 3t plus 1 divided by 3. Y is equal to 3t plus 1 over 3. That's my second point. So this is parametric form. Have I done it wrong?
It's minus 1. 3t minus 1.
Oh, the minus, I didn't. That's an equals minus 1. Yeah. Thanks. And then x will be, 2x minus 1, 3t minus 1 over 3, minus t is equal to 5. And now we solve that for x to form parametric form. So this is one parameter. This is what all the y's will be. And all the x's will be this one, which I don't really want to do out, but we will.
Just multiply everything by 3.
Yeah, probably the easiest thing to do first. 6x minus 3t plus 1 minus 3t is equal to 15. Bring everything to the t's to one side. We get 6t, and you're telling me that's minus 14, and then divide by the 6. You can simplify that a little bit, but I may have.
That's your answer?
Yeah, so our answer is a line. You know the way we write a line in parametric form? This is the line in You could put it into a line. You can go x, y, z form if you want, and you can use your vectors to. We have a position vector.
That's cool.
Okay. So that's what we did before, and I said wait till vectors, and it'll make a bit more sense. So hopefully it makes a bit more sense now. Now, a very common question is the next one I'm going to show you. Not that one. Not that one. That one. So remember we were doing equations of lines in vector form? We could write them in parametric form. We got this a lot.
So that's the line of the actual.
Yeah, yeah. I was saying to the guys there, we can put it back into this form if you want. Yeah, and put t here. Huh?
Could you write in that form? I just want to see like.
No.
It's going to be messy. It's going to have fractions in it, but yeah. So that's a t. Yeah, so let's just make sure. So 14 over 6 is 7 over 3. So 7 over 3. Y then would be minus a third for position. And t is 0. And then t is, for x, it is 1, thanks. 1, 1, and 1.
Oh, because it's in the straight line anyways.
Yeah. All right, nice. Okay, this second question then is by far the more common to like interpret your like there's a free variable or a variable knocking around there in the question. So let's deal with that, and then let's see. Maybe I'll change color of pen. Different question. New question, new pen. Okay, so we've x plus y plus 3z is equal to 2. 3x minus y plus 2z is equal to 5. And then we have an a here in the, so we have this. And we're going to turn it into a matrix. I guess we're going to check for parallel. Anything looks like they're the same line or the same plane, or I don't think so. Not from what I see anyway. Okay. So just do check for that beforehand, otherwise you're just wasting your time. You'll get a inconsistent answer anyway, or they'll cancel out pretty quickly. 8, and that's an A, not a 9. That's an A, isn't it? All right, so we've got to solve this down. There's going to be an A in our answer, and then we're going to put different values in for A, and we're going to say where there's no solutions, and you can see here it's coming up. Where there's no solution and infinite solutions. Okay. 1, 1, 3. This thing. Yeah, so row echelon form is when you get. Yeah, it should be 0, 1, 0, 0, 1 in those positions. Okay.
Does that just happen naturally when you're solving it?
Well, we usually just get 0.
Just skip that bit because you can do like 3x, like 3y minus 3z.
Yeah, and we know that this is 3x, 3y. We don't care if it's just 1 or 3y and 3z. We don't care if it's 1y. Because we can always find 1y by dividing by 3 later. Okay, first thing, always use row 1 first twice. So we're going to use row 2, take away 3 times row 1 here. That's going to give me a 0 here. Row 2 is minus 1, what's that, minus 4. Do double check my things because. Okay. 2 minus 7, thanks. 5, 1. Oh, okay. 0 again here, so we're going to go row 3, take away 5 times row 1 this time. So, 1 minus 5, minus 4. This. Uh-oh. Okay, and A minus 10, is it? Is it? All right, so I need this down to well, let's no, let's not put that. Let's get a 0 here. This is an easy to get 0. Subtract row 3 minus row 2. I think they need to change signs, don't they? So that's 0. Oh, plus is it? No. Minus. 0, 0, and we get A
negative a plus 10.
I did this, take away this.
So negative a plus 10, no?
Isn't it just positive a? A minus 9. Now I should get this to a 1. How do I get this second line to a 1 here? No, it's this, take away that. Yeah. So just divide by 4. I think we can answer it without doing that, but divide by negative 4, or what I would say is multiply by negative 1 over 4 to get this. That'd be a 1, then that'd be 7 over 4, and that'd be then a quarter. And then I have 0, 0, 0, a minus 9. Okay, that didn't really change anything for the a minus 9, it's just...
Wait, why don't you need that other one to be 0, like in the small one?
You're looking for... I wouldn't worry too much about this. I've never seen anyone penalized for writing it like this and then drawing conclusions. Let's go with this one. I think the 0, 1 is just confusing, but let's continue on anyway. For what values of a does the system have no solutions?
9. Oh, sorry.
So we have no solutions, and the other one option is infinitely many solutions.
So B is, C is 9, right? C is 9. B is any value.
One of them is a doesn't equal 9, and one of them is a equal 9.
Yeah, no solutions is the
A,
one where it's
Not equal to that.
so this one is the not.
Yeah.
Wait, why is both of them
No,
equal
no,
to
no.
9? No solutions equals a.
No, one of these is wrong. One of them should have a line through it, not equal to
No
it.
solutions should have a line.
No solutions? Why?
Because otherwise it has
If that one has
If we have 0, 0, 0,
anything.
10,
then it would just be
So no, 8 has to equal 9 for that one.
no.
Yeah. But
Josh, when it's 0,
but
0,
just on
0,
the previous
0,
one,
0,
said that 0, 0, 0, 0 to have solutions.
Josh
Just
said
goes
it.
forward. Yeah.
so for infinite solutions, we want 9 here, and that'll make a 0, 0, 0, 0. That'll be infinite solutions that will look like a line. That line contains loads and loads of x, y, z values that will all work. So that's infinite solutions when a is 9. So the answer would be they meet a line here. Infinite, does it say some sort of geometric? Okay, meet at a line. Now we could find that line by letting a equal to 9 and then finishing off the question. Maybe we'll do that in a second. A equal to 9 and then z will equal t, finish the question. A does not equal 9, no solutions.
That means they don't meet at all, right? They're parallel.
No.
Are they parallel? We dismissed that at the start, didn't we though?
Oh, yeah.
So which one
When they have like
Which one of our ones is that?
It'd be
Which one is, if A is 9, or sorry, A is not 9, so we get like 0, 0, 0. Let's say A is 10. We get 1 here.
what, 2 parallel and 1 intersecting?
Are they parallel?
Are there any, there aren't any parallels in 8, right?
Oh,
Oh,
so
8.
It's 8, yes. We dismissed parallel, and there's none the exact same either. So the only one it could be is 8. And look at the reading of that. The line of intersection of any 2 is parallel to the third. So you can see there, this line will be parallel to this plane. This line is parallel to this plane. You can see that they're...
It's because they make a triangle.
They make it, yeah, an A shape or a triangle, yeah.
Josh,
Yeah.
because this is here. The last one. The point
oh
where
yeah,
Josh-
they have to, otherwise
Yeah.
it'd be 6.
Yeah.
That's gonna be parallel.
Okay? So this is quite a common one. So no solutions. So what do we say? This is the geometric interpretation. The line of intersection of any 2 is parallel to the third plane. Yeah, it is a good line. In other words, they make an A shape. So this intersection line is parallel to this plane. And all intersection lines is a line along this one, and it's parallel to this plane. And the intersection here,
Can't you just say that all intersections are parallel to the planes, but not all the planes are parallel to each other?
yeah, something like that. Yeah, that's probably the same. You're saying the same thing.
It's like the intersect between like the blue and green one is going to be parallel to the blue. And
That's what it says. That's it.
Okay.
Yeah.
Okay.
So this is the line. Whether you learn this line off or not, you're probably not going to learn it off. Maybe you will, but understanding what it looks like, just think the A shape or the triangle shape is if it meets like this. And when is that? When we get some sort of inconsistency in that last line. So 0, 0, 1 is when we get something like that. The meet at a line, when we get at the last line is 0, 0, 0, 0. They meet at some line, and that's when we go z is equal to t, like the previous example, and we finish it. It'll often ask for that line. And then if we've ruled out all parallels and all that, and you've solved it, and you get an actual answer, that is when you get 0, 0, 0, like A and B, A equals B. And you get an answer. You get an actual answer. That means they meet at a point. That meets at a point. This one meets at a line. And this one makes an A shape, as long as they're not parallel to each other.
Would they ever ask you to find the points of all the intersections between the plane if you get like 0, 0, 0, 1?
You're looking for all these intersections? No. You'd need more information.